So another thing that I can do with macros, let me go ahead and clear the screen here, is define our use a similar idea to define like a macro function. Uh, so say I wanted to add two numbers, right? So I'll have here int add int a int b, and we'll just return a plus b, right? And what happens if I wanted to work with doubles, right? Or with floats, I mean, so we'll say int add double A, double B. Oops, that should be a double here, and an int. In Java, we can, we can overload the function, and we'll just say return A plus B here. Let's go ahead and run this and see what we get. So I'll say here clang slist.c. You see in C you cannot overload functions. The way it works is it's looking at the symbols. So it says, hey, you defined, and we'll see what I mean. If when you take systems, you'll understand how the linking works. But right now it's seeing two symbols. There's one symbol add and there's another symbol add. Right? So it doesn't really look at the whole signature, just at the symbol. So it says, hey, you have a conflicting types for add. One is with ints, the other one is with doubles, right? It doesn't, the return type, you might think that I have to change the return type, but I doubt that will work either. So even if I did this here, and I ended up, casting this as an int, let's see what will happen if I run this. Oops. So we'll do here. Let's see. Still, it didn't really matter. So how there's no generics in C. In Java I could change this to a generic t parameter, right? The int will become a t, this will become a t, etc. Now in C, I can mimic generics with void pointers, or I can use macros. So let me show you how I can do this by using a macro. Okay. So I'm gonna go ahead and just comment this out so we can write the macro. So for my macro now, it's not that difficult really to write. We'll just say define, and we'll call it sum or add, whatever we want to call it. And like before, we're going to take two parameters, x and y. I'm not specifying what they're going to be. And then following the example from above, I'll just say x plus y. Note the difference here, guys. I'm not saying return x plus y. The reason why I'm not saying return is, remember what the preprocessor does. It does text substitution. Okay, so there should be no return statement. So I'll just say x plus y. And let's go ahead and we'll try to call it here. So we'll say int result equals, right? And then I can just say sum, and then I'll say 2, 3. And let's see what this gets pre-processed to. So we'll say here cpp slist.c. Look at that. Look at the pre-processed result here. Let me bring this up a little bit. As I told you, this will just get replaced, right? So I use the sum. I replace the symbol x and a y with a 2 and a 3. So essentially what I put here, that's what it's going to get replaced with. It doesn't mean it's going to be right. I can say hello, let's do hello, and this doesn't make any sense, but the preprocessor, let's see what happens when I run it with the preprocessor. It's just going to say hello plus there. It doesn't really care if this is going to work or not. Let's see if I do random text. and we'll just leave it as hello. And then I run it on a preprocessor. See? So you can pretty much mimic this to just replace text, and then work it like that. So you know, if I say 2.5 and you know 3.4, and I run it through the preprocessor, the preprocessor is just gonna replace that texting. So see, whether it's gonna compile or not, that's a different story. But if it's valid, you know, it will compile. So if I go ahead and change this to 2 and 3, and I actually run the code, so go ahead and okay, so that's the preprocessed file. This is the file that will get compiled. So we'll say clang slist.c. Well, it's not. I didn't print the value, but at least it ran, right? It didn't complain. We get a compilation error. All right. So I mean, I can go ahead and print the result. Oops. So I can just say printf. Right. So it worked. Right. The main purpose was to see that we'll compile. So I hope this made sense. I'll stop the video right here, and then I'll see you in tomorrow's lecture, where we're going to talk about some other things. We'll see if we'll keep working on the linking part, or if we'll move on to creating a abstract data type for our assembly linked list. Okay, thank you for watching.